Okay, good morning everyone. Thank you for coming to my talk about UNTestable. So you're here because probably you like pain. Either you like seeing me in pain testing the UNTestable, or you would cry seeing how painful it is and you relate to how untestable some of these examples would be. So who am I? I am Shi Ling, and I started out as a web developer more than 10 years ago. And this was back then when we were mostly building websites on jQuery. Then it got more and more complicated. I was helping some of the teams I worked with migrate the front end from jQuery to Angular, from Angular to Vue.js, from Vue.js to yet another framework, and so on and so forth. And I'm really, really obsessed about organizing code and refactoring code, which is part of the reason why I like to do TDD. And a big reason why I test is because I'm a very neurotic person. So on nights of deployment, I would be up at night thinking about, oh no, is there a bug? Is a customer going to call me tomorrow telling me that something is wrong? So I started writing tests, and then it became a mission, and then I joined the dark side, and I thought it was, hey, this is kind of fun, torturing developers all day, telling them, you're wrong! Yeah, so now it's my mission, and I created UIlicious because I want to make testing easier, especially for people who are very new to programming, very new to Selenium, and they want something, easy stepping stone to create a test. So untestable, how hard can it be? It's just pressing a button. So why did I choose this particular topic? To give you some context about what I do at UIlicious and why it's UIlicious is that UIlicious is a platform for automating browser testing, and it's a local platform. We use WebDriver protocol underneath the hood so that it supports cross-browser testing. And our core philosophy is to test user journeys, not HTML. So the test language is designed to be really, really simple, semantic tests that are easy to read, they are meaningful, they are easy to understand even if you don't know how to test, and they are really low maintenance. So this is what a test in UIlicious look like. It's very simple. Go to github.com, fill in email, fill in password, click on login, and just do a simple validation that you see your teams on github.com. Now, this frustrated me so much that I had a lot of white hair just trying to make sure that clicking works, and that's why I dyed my hair green. So why is this so frustrating? I had the most bug reports on the click command. We have testers coming to me and say, hey, why isn't this working on this page? And they would send me the URL or send me like the component and say, it's not clicking on this page, not working, getting some kind of error. It works fine if you press manually, but it doesn't work if you use the test command. An automation engine isn't working. So I was super, super frustrated. And they say, like, oh, it's just pressing a button, right? It should be easy. So, and then they would prove it to me, like, look, if you press the button, it works perfectly. But unfortunately, if you inspect the code and you look at how the button is programmed, it's programmed in a way that breaks browser automation code. So I'm going to show you some examples over later on, and also how I work around some of these issues. And there are some workarounds for these untestable buttons. That when I mean untestable, they're not completely untestable. It's just that they're not designed for testability. So there are workarounds, but because our users are typically very new to test automation, they are usually not familiar with Selenium itself. So sending them a workaround code, they're like, oh, what is this alien piece of code? And it sort of goes against our sort of philosophy of having this test that our users are writing to be readable and maintainable. And then what if you could ask the devs to make it more testable? And then they're like, but it works for humans. I'll fix later, I'm so busy. So it's impossible to ask developers to make their front-end code more testable. Some might, but usually they don't. Like, it gets put in a backlog, means it never gets done. Yeah, so I gotta make this work 100%. Super determined to make this work 100%. So, and that's been a lot of my work for the last 6 years, just making sure that click works all the time. So I made a site called the untestable site to demonstrate these untestable components. So let's have a look at the untestable button number 1. So the first button, and a lot of the buttons that I'm demonstrating today, I would demonstrate the ones that are most common that I've observed, but definitely there are more. And I had fun going around asking folks yesterday about their own horror stories, and everyone had some kind of untestable scenarios that they shared with me, and some of them might be solvable with some of these demonstrations. So untestable button number 1 is the glass door. I call it the glass door because if you press it, the button is laid underneath another overlay element, and that's usually for cosmetic effects, like you have an image and maybe a product team or design team say, hey, we want to add a color filter or like a nice overlay and make it prettier. So let me show you the glass door. This is the untestable side, and let's go to level 1. So if you want to try yourself, you can read the level information beside and test it out with your own test automation framework. And the goal of this level is to click on this button, Visit Chicago, and if you click on it, you get like nice, pretty confetti, yeah! Okay, so let me show you this particular test, how to test this with vanilla Selenium JavaScript. Okay, so over here I have my test. And let's go ahead. So I'm going to skip all the boilerplate stuff, and we're just going to jump into testing the Visit Chicago button, which has an ID, which is Visit-Chicago button. So we're just going to use vanilla WebDriver here. So let's do a await driver.find element. We'll look for the button to click, and then we'll click on the button. So we'll run this test over here. So this is the first test that we're going to run with the vanilla Selenium JavaScript. And nothing happens, no confetti. And you can see what's the issue over here. You can see that the arrow is pointing out that you get an element click intercepted exception. And it says that this button is not clickable at this particular point in the viewport, and the another element will receive the click, and that is the label for Visit Chicago button. So let me show you what this looks like underneath the hood. So we inspect the element, and you can see we have a button over here, and on top of the button we have a label, and if you as a human click it, it works perfectly fine. There's no JavaScript, custom JavaScript involved, by the way. I wanted it to keep it simple, so it's just a label that is binded to the button. So if you click on the label that is binded to the button, it actually bubbles and propagates to the button itself. So yeah, more confetti. So what is this element click intercepted error? So you get this error when the element that you're trying to click is received by another element that is not the target. And in this case, we actually want to click, it doesn't matter whether or not the click clicks on the overlay element, because in any case, the overlay element is designed to propagate the click to the target button anyway. So it's fine. And how should we solve this? So the solution, so some of the tools we'll be using today just to explain is we'll be using Selenium JavaScript, which supports the WebDriver protocol. I wanted to make sure that we have a solution that supports all browsers, and also absolutely no JavaScript clicks. That's cheating. Please don't use JavaScript clicks if you're going to try this at home. Okay, and we'll have Mocha.js on top as a test framework. So on my IDE over here, which is Visual Studio Code, I have a plugin to help me quickly execute Mocha test on the side. So let's try to solve our untestable glass door. Okay, let me go to this. So I created a helper class, and I decided to name it the finger. And it's very magnificent. It's already been imported, so let's initialize the finger. Var finger equals to new the finger. And we pass in the driver so that it can use the use WebDriver to execute the click. And what we'll do is we'll very similarly say await finger.click. the button to click. So it's really simple. And now I haven't implemented the click command itself. So let's go and jump into our click command, and let's implement this. So the steps to clicking on our untestable button is that what I'm going to do is first find the position of the button, and then ask the browser what is the thing that is on top of the button at that point that will receive the click. And instead of clicking the button, we'll click the label instead. Okay, so first thing first, let's find that element. So we have passed in the locator. So what we're going to do is we're going to say var element equals to await driver dot find element, and we'll find the element. So we'll save the element reference locator. And now what we're going to do is we're going to execute JavaScript, sends a piece of JavaScript to the browser to execute. And step one is we are going to ask the browser what is the size of this, size and position of where is the bounding box of this element itself. So let me press equals to await, and we're going to send a script over, execute script. I'll pass in the element, and first thing first, we are going to ask what is the bounding box rectangle for this element that we have passed in. So it's very simple. You can grab this, and if you want the documentation for the bounding, what is the bounding box rectangle, you can go to, you can click on this link. The Untestable site is open source, so you can actually read the documentation, and if you want to know more, you can check out the Mozilla developer notes on this. So we get a rectangle. Now we want to know where's the center point to click on. So var x equals to rectangle dot left. So this is like the left edge of the box of the element that we want to click on. Plus, and then we want to click on the center. So from the left, we want to click like 50%. So we'll do rectangle dot width divide by 2. I'll do the same to figure out where is the y position of the center. So element dot rectangle dot top, this is top edge, plus the half of the height of the box. Now we have x and y. Now in order to find out what is the element that is on top of this button that we want to click on, there is a very useful API, web API you can use, which is element from point. So what we'll do is we'll grab that, ask the browser what is that. So you can do document.element from point, and you pass in the x and the y coordinates to query and ask what is the top element. And then I'm also going to pass in the HTML so that you can print it out for debugging. Okay, so we'll return all of this, return x, y, top element, and top element HTML. Finally, we have the, once we have this returned to the testing script, we are going to use the WebDriver click command to click on the top element instead. So we'll do await driver.click, wait, wrong. I will have the response here. Oh, let me deconstruct that, x, y, top element, and the top element HTML. Okay, so what we do is we will await the top element dot click. Okay, so we get the element reference back from the response of the driver.execute script function, and we'll click on the top element instead. So let's go ahead and run this test. Yay, confetti, it works, yeah. Okay, so that is how to solve for the glass door. Okay, so let's look at our next untestable button. Our next untestable button is infinitely re-rendering UI components, and it happens so fast that it's not perceivable to humans. And this is unfortunately very, very common with a lot of modern frameworks. So I've even made these mistakes myself when I used to code in Angular, in React. And if you look at Stack Overflow, there's tons of posts about like how do I like avoid unnecessarily re-rendering the component in React, in Vue, in Angular. It's a really, really common problem. So let's have a look at our cloning example. Let's go to the next level. And here, exactly the same example. You can click, it works for a human being, but if you inspect the code, you can see that is impossible to inspect this bloody button. Let's try to expand it, but yes, it's re-rendering every 500 milliseconds. I can show you the re-rendering code over here. Oh, this is the confetti code. Yeah, this is the re-rendering code, and set to re-render every half a second, which is even if I set this to 200 seconds or like slower, I mean, half a second is not slow enough for humans to perceive that this is re-rendering. So to a human being, it looks perfectly fine. But to the automation bots, like there's something really wrong about this page. So let's test this with. Let's test this with the vanilla JavaScript code, vanilla Selenium JavaScript first. Let's go ahead and run this. Yeah. And see what sort of results we get from the vanilla JavaScript. So we get an error, and this time the error we get is the stale element reference error, meaning that the element that you're trying to click on has been detached from the DOM, and that is because it's being infinitely re-rendered. And I have another implementation. This time we'll use the magnificent finger that I created in the previous test. And it is also going to be, this one will be unstable. Sometimes it will pass, sometimes it will fail. Let's try our luck right now and see if that works. Let's go ahead and run this test. Yeah, so we get the same issue here, a stale element reference error. So if, it just simply means that the element that you're trying to click on and target is no longer existing on the page. So how do we solve for this re-rendering problem? So let's work on the problem. Let me close this, and now we can have a look at our test over here. So I've already initialized the finger, and I want to click on the Visit Chicago button again. So let's do the implementation of clicking on this. So we're going to do something a little bit different. So instead of trying to click on the top element, we will try to move the mouse to the position and then fire a mouse button left and then release it using the actions command. So because the code for querying and finding the element is a bit long, in order to save time, I just written this part. And let me just explain what is this doing. So there's two parts to this. There is actually a retry, automatic retry and polling mechanism. So what this does is that it's going to keep retrying this function that will try to find the element and get the position of the element. And then it will have a condition for stopping the retry. And by default, it's set to retry for 15 seconds. And you can actually change the threshold, but for me, I think like 15 seconds should be a good enough time for us to be able to grab at least one of the clones and find out where's the position of it. So this time, we have the locator that is passed in from the script itself. And we will use, if you look at the by selector underneath the hood, it has using. It will tell you whether you're using a CSS selector. If you're using ID, it translates to a CSS selector anyway. If you're using XPath, then it will say locator.using property will be XPath instead. So we use different methods, web APIs to figure out, to find the element, to query the element. So if you're using CSS selector, you can use query selector. If you're using XPath, then we'll use document.evaluate instead. Okay, so same here. If we found the element, then we are going to get the rectangle, find the center point, and return all of that information back. If we don't find it, then we'll return element is null. And if the element is null, it's going to keep retrying until element is not null. So now that, given that I have the element returned from the finder function, what I'm going to do next is I'm going to use the actions protocol to move the mouse to the center point and then fire the left mouse button and release it. So how do we do that? Let me show you. So we're going to create actions dot driver dot actions. Okay, and then actions dot move. Oh, and then make sure that we remember to add a wait because it's JavaScript. So we're going to move to the X position given by our response over here. So response will give us X and Y, X and Y. So we move to response.x, and Y will be response dot. And another important thing to add is also the origin. Because when you ask the DOM where is this thing using the bounding client rectangle function, it will give you X and Y. The top and the left will be relative to the viewport, meaning relative to the scroll position of the page. So what you have to do here is you want to say the origin of X and Y is relative to the viewport itself. So we move the mouse to the X and Y position where the element is, and then we'll press. And by default, this press the left mouse button, but if you want to be very explicit, you can say button.left. And then we will release the button, and then we'll perform this action. Okay, so let's go and test our new upgraded finger. Hey, it works. Fantastic. Okay, so now let me show you the next untestable button. It's not technically untestable to vanilla Selenium, but it is untestable to the finger, and that we need to upgrade our finger further to be more powerful. So this one is, I call it Dodgeball, and I've seen this on a few websites where they want to show you a promotion, a hidden promotion or hidden advertisement. So when you move your cursor over the element itself or the container, it expands. And as a human being, what you would do, you'd be like mildly annoyed, but you just reposition your mouse and click on it. And but the automation bots, they can't figure out how to do that. Or at least the finger at this current version doesn't know how to do that. So let me show you the Dodgeball. Okay, so this time we want to click on the login button. And we'll move to the login button. I can't click on the login button. If I'm a human, I would just move my cursor and click on it. And yeah, confetti. Okay. So let's just run the current version of the finger against the Dodgeball first, and let me show you that it doesn't work. So it clicked on the cat's hand, but not the actual button itself. So I have an error over here that says the element did not receive the click because I have a logging output on the side that prints out every time if you are successful that you have clicked on the button itself. So we're not successful in clicking the button, so let's upgrade our finger code. Okay, so let's go to our workaround and upgrade our finger. So this time, what we want to do is we want to get the position of the button and then wait for a few seconds for the animation to complete. Sometimes they take up usually like less than a minute. less than a second to complete the animation, and then go and find the element again, recompute where is the position, then we actually click on it. So we have over here, I moved the code that we have previously to find the element into a find element function itself, so that we can reuse this piece of code and don't have to copy and paste the whole chunk. So first we will find the position of the button, and then what we're going to do is we're going to do what we did just now, which is to move the mouse, but instead of pressing the button, we don't press it yet. We will sleep for a little bit for the animations to complete, and then we will call the find element function again to find the position of the new position of the button. And then at the second time round, you will click and release the button instead. Okay, so let's go ahead and run this fix test. Aha! We've caught the moving login button. Okay, so now the last example that I have that makes the finger incomplete, and we have to, and the finger will not be able to solve that yet. So let me show you is what I call the Russian doll, where the element is inside a scrolling container and it's not in view by default. So you have to move, you have to, the actions protocol will not, will only click at the position on, as you said, on the viewport, but it does not know how to scroll yet. So I need to tell, to upgrade our finger, we need to tell it how to scroll. So let's have a run with our new, the finger, the current version of the finger, with the Russian doll demo, yeah. So this is not going to work, and if you have a look at this, we will see that the error is, the actions protocol will give you an error that says move target is out of bounds. And when you see this error, it means that when you try to, it only happens if you use the actions protocol to move something within the viewport. And it means that the position that you're trying to move to is invalid, is outside of the boundary of the viewport itself. So what we have to do is we need to scroll our element into view. So this is very easy to fix. So let's fix our code over here. So let's go to our code, and and now we have to fix the find element function, which is incomplete. So what this does is that we get the rectangle, but before we get the rectangle, we want to scroll into view, because you have to remember one thing about as I mentioned before, the bounding client rectangle method. It gives you the left and the top position relative to the viewport. So that means that you must scroll first, and good thing the web API has a pretty robust scrolling function. So what you want to do is just call the scroll into view function. Scroll into view. Okay, and that's all. That's all you need to do to fix this function. Okay, so let's go ahead and run this test. So this is a scrolling menu inside a scrollable page, and it's not viewable by default. So you have to scroll down to view the form, and then you have to scroll within the menu to view the select the option that you want. So this only works if you click on Singapore, which is the nice warm country that I'm from. Yeah. So you can see. Human can do it, and now we have a magnificent finger.click function that can do it as well. Yeah, so that is the ultimate finger, and let's run, let's to make sure that this all works, like the final ultimate finger works, we're going to run one final test that combines all of the tests together. And this code, I have open sourced it, so you can go to GitHub and search for Selenium Finger. And if you want to fork it and make a Python version of the Finger code, or you want to expand it to WebDriver IO or Water, you can have a look at the source code over here and try to modify it to your testing tool. Yeah, so it's all like it's opening the individual exercises and making sure that this test works across all levels. Okay, so that is the final finger. Now I have a bonus round for all of you if you want to stretch your creative muscles, which is the bonus round, the running yarn cat. And it's coded horribly. You can inspect the code to find out how I animated this. It uses some of the untestable concepts that in the previous round. So I hope you have fun trying to test this. I will not show you the solution. To be honest, I don't have fun, but I know how to solve it. Yeah, so have fun. And that is all for my demo. Okay, so if you want to contribute and help me add more to the untestable collection and also share how you solve these untestable components, feel free to fork the untestable repository, add a new example, or please also add a test for your untestable component to show people how you solve this, and then let me know, and I will, if it looks good, I'll publish it as a new level. And then, yeah, and if you want to, as I mentioned, if you want to extend the finger for your own JavaScript tool, your own Java testing library, etc., you can find it on Selenium Finger on GitHub. And you can also, I'm available on Twitter. If you want to tweet me or you want to follow me, you can follow me. And also, if you are interested in trying out UIlicious, we also, I'm happy to offer 1 month free, so you can go in and give it a try. So underneath the hood, UIlicious uses some of the concepts I demonstrated in the finger today to click on the untestable buttons. And that's it. Thank you, everyone.